Ahmad, turn the video on. Aaron. Yeah, thank you. Turn the video on, Aaron. Yeah. Ahmad, please turn the video on, my dear. Okay, two sentences only related to the reverse characteristics. As we have seen that the reverse characteristics current is due to minority charge carriers drift across the junction, and this small current will not be varying with the bias voltage that much. Okay, so you can almost say that's a saturation current, almost constant. So it's only a few microamperes, very small current you will be getting because the minority charge carriers are very less in number. Okay, and also at a particular point, for a particular voltage, or you can say for a sufficient bias voltage, breakdown of the junction will be happening. Okay, so when breakdown of the junction happens, what will happen? The charge carriers will be uh, flowing through the junction. So that will be increasing the current rapidly. Okay, so that particular point is called as Zener breakdown voltage, or you can say it as avalanche breakdown. Okay. You are not having that two things to learn for detail avalanche breakdown and Zener breakdown. There are two mechanisms to cause this breakdown, but you don't have that much to learn. Okay. Okay. Hope you might have completed. Only two terms are there. Okay, so this is the characteristics of PN junction. Forward characteristics and reverse characteristics, very important. The graph is also important. The circuit is also important. The features of these forward characteristics and reverse characteristics, including the terminology, is also very important. Okay, so now you can see a small point over here, resistance of a diode. Okay, write down this one, resistance of a diode, like static resistance, or we will call it as DC resistance. Same thing, resistance as per our Ohm's law, you are having an equation V by I. So if it is static resistance, you will be writing it as V by I. Dynamic means whenever there is a change occurring, okay, continuous change is occurring, that is called as AC resistance. So that will be given as delta V divided by delta I. Only the term that you have to remember. Okay, so it's a ratio of small change in the applied voltage to the change in the or corresponding change in the current delta I. Okay, you simply need to understand these two terms, the equations, because dynamic resistance you may be asked to calculate. You can calculate that from the slope also. Okay, so by calculating the slope of the graph, forward characteristics, VI characteristics, you can find out the static or dynamic resistance. You can calculate from there also. Okay, so this is the important topics related to PN junction. We understood what is PN junction, what are the two mechanisms that we can see in PN junction, like drift and diffusion of majority charge carriers and minority charge carriers we discussed. Then we discuss how we will be biasing a PN junction diode, forward biasing and reverse biasing. Then we discussed what is the for VI characteristics for forward biasing and reverse biasing. The features, important features of this VI characteristics also we discussed. Now we just discuss what is called by dynamic resistance. What is the equation for the dynamic resistance over there? Okay. Now this junction diode, PN junction diode, is a unidirectional, having a unidirectional current characteristics. What you mean by unidirectional current characteristics means when the diode is biased, like forward biased, it has a very low or very small resistance. Okay, and current will be flowing through it. But when it is being reversely biased, the resistance will be increasing and current will not be flowing through it. So the diode can conduct only in forward bias condition. Means the diode will be conducting only in one direction. This property of this diode can be used to make several devices, including a rectifier. We are going to see what is called as rectifier. So remember one thing, a PN junction diode is a unidirectional device. What it is? Unidirectional device. Just write down a point over there. Beneath you wrote resistance of a diode. Write down it is a unidirectional device. What do you mean by unidirectional device? That is, the diode can conduct only in one direction. The diode can conduct only in one direction. That is when it is forward biased. That is when it is forward biased. Just add these 2 points. A diode is a unidirectional device, means it can conduct only in one direction. That is when it is connected in forward bias. Only these points you need to write. Okay. This property of unidirectional current characteristics makes diode to use it as a rectifier. Okay. So in order to convert AC into DC, rectifier means converting alternating current into direct current. Okay. Alternating current is a fluctuating current. DC current is a unidirectional current. So the device, the PN junction diode, can be used as a rectifier. A rectifier is what? Or rectification is what? You can see over there. The process of converting alternating current into direct current is called rectification. Okay. The device used for rectification is called as a rectifier. The PN junction diode offer low resistance in forward bias and high resistance in reverse bias. Okay. Just write down the heading. PN junction diode as a rectifier. Then you write down the written part. Do not draw the circuit diagram. I will tell you how to draw the circuit diagram. Don't draw the circuit diagram. Just write down PN junction diode as a rectifier. Then write down what you meant by rectification and the features. Rectification, what it is? Converting AC into DC. AC is an alternating current. It will be fluctuating in both directions. And that fluctuation we will be cutting off and we will be making it into unidirectional. Positive cycles only. For AC, you're having positive and negative cycles. Now, one negative cycle, the negative cycles we will be cutting off and we'll be making that into only positive cycles. So only one directional current is there. AC is a bidirectional thing. Okay, positive direction, negative direction. Okay, positive direction, negative direction. Whereas this one, what? DC will be having only one direction. So here we are utilizing the features of PN junction diode as a unidirectional current device. We will be utilizing this one in order to use what? In order to use it as a rectifier. Okay, just write down the what you meant by rectification. Then we will start to discuss what is rectification or how rectification is happening in a half wave rectifier. Abdul Aziz, turn the video on. Okay. Now, once you complete that writing, PN junction diode offers low resistance in forward bias and high resistance in reverse bias. Okay. Continuing, you need to write a few more sentences related to it. That is, it conducts, that is, it conducts current, that is, it conducts current only in one direction. Only in one direction. This unidirectional property of a diode, this unidirectional property of a diode, this unidirectional property of a diode unidirectional property of a diode enables us, enables it, not us, enables it to be used as a rectifier, enables it to be used as a rectifier. Okay. Now listen to me very carefully. So I told you for AC, you are having positive half cycles and negative half cycle. So when you are applying an AC signal to a diode, suppose first the positive cycle being fed to the diode. So the diode is having positive to positive connection. So it is forward bias. So the diode will be conducting. Okay. Now, immediately after that, the negative cycle will come. When the negative cycle comes, the negative cycle will be connected to the positive part of the diode. So negative positive connection means it is reverse bias. So the diode will not be conducting. Okay. So during positive cycles, the diode will be conducting because positive to positive, if you are connecting, the diode will be forward bias and it will be conducting. But when the negative cycles been connected to the diode, positive part, then it will not be working. The diode will not be working and you won't be getting an output. So output will only be having that positive cycles. Okay. That is what you are seeing over there. You can see. See the circuit over there. The circuit contains what? A diode. This is a diode. Okay. And this is what? This is symbol for what? A transformer. We will be learning that in electromagnetic induction and alternating current. Okay. Step up transformer or step down transformer we will be utilizing over there. Now, so that is just to increase the voltage. That only the case. Okay. Nothing else. Increase or decrease the voltage. That is the use of a transformer. Now, this is the AC signal that we are mentioning. You can see the third diagram, this one. Okay, the other one is been splitted. See this one. This is the positive half cycle, the yellow part. Okay, this is the positive half cycle. Okay, and this is a negative half cycle. Again, positive half cycle. Again, negative half cycle. Likewise, it will be coming. 1 second. One second, give me a sec. Okay, so what I was saying, the third one that you're seeing over here. Okay, see here, this is an AC. An AC is represented like this, a wave. Okay, which will be having, if you are drawing a cut, this one, it is positive half cycle, negative half cycle. Likewise, it will be going. So look at this one. So the positive half cycle is denoted by yellow part and the negative cycle is denoted by green part. So positive cycle and negative cycle will be given to the diode. And the diode, see how it is connected. This is the P side and this is the N side. Now imagine we are giving, or the positive cycle is reaching out to this particular PN junction. So when positive cycle is reaching over there, this is positive in nature, right? So when positive reaches to the P side of the junction, positive means what? It is forward bias. So when it is forward bias, the diode will be conducting, and the diode conducts, and across the load resistance, you will be getting the positive cycle. First positive cycle we got. Okay. Now, second one is what? This negative cycle. So this negative cycle goes to the diode. So when negative cycle comes, that is negative. Negative to positive means what? Diode will not be conducting. So this negative cycle will be cut off, and in the output, you will not be seeing the negative half cycle. Okay. Now again after that, what will happen? The positive half cycle will come. And the positive half cycle will make the diode again forward bias. So that positive cycle will be appearing across the load resistance. And now the second negative cycle comes. Again the diode becomes negative, means reverse bias. Diode will not be conducting. So the negative cycle will not be appearing across the load resistance. So all in all, total, we will be having only positive cycle. Means unidirectional. Positive cycles only we are getting, not negative cycles. You got this one? Clear or not? Okay. So the same picture being separated into positive cycles and negative cycles into this diagram. Means positive cycles are only giving, you are getting an input, output, right? Now, when you are getting negative input, you are not having any output. Okay. Combining these two, we will be having a diagram like this. You got this one? Clear? Understood? So remember one thing, rectification means what? We would like to filter off the alternating property of current. So AC we will be converting into DC. Okay. For many appliances, we need what? We need DC current. We don't want AC current. The supply that you're getting at your home is AC. Means that it has to be converted into DC for many of the devices, including the charger of your mobile. Okay, so you wanted to filter off that AC part. Alternating part you have to filter off, and you have to keep it as unidirectional, single direction current, or DC current you have to make it. Okay, for that we will be utilizing the property of diode as a unidirectional device. Means diode will be conducting only when it is connected in forward bias. So when you are connecting the AC current or the device, the PN junction diode, if you are connecting to AC signal, for the positive half cycles, diode will be forward biased and it will be conducting, giving you an output. But for the negative half cycles, diode will become reversely biased and it will not be conducting, and hence there won't be any output for negative symbols. So only the positive cycles will be appearing across the load resistance. Hence, you have now unidirectional current. Hope it is clear to you. Is that clear to you? Okay. If it is clear, then you draw this third one. Third circuit only you draw. You need not to draw this one. No need to draw these two first two diagrams. You need not to draw. You draw this third one. That's enough. Need not to draw the first two. Okay. Draw the third one. Then I will be giving you the explanation.
Dear students, Reem, Ahmad, Aaron, Wafik, Jisna, Krish, Minha. Your face is not clear. Even though the video is on, your face is not clear.
Complete the diagram. Fatin, Amar, Azim, please turn the video on.
Okay, അല്ല 20 കണ്ടെങ്കിൽ ഇപ്പൊ വിളിക്കും.
Please turn the videos on. Those who join, please turn the video on. Fatin and all, please turn the video on. Okay. Completed the diagram. Hope you have completed drawing the diagram. Only the last diagram you need to draw. No need to draw the first two, only the last diagram. Okay, need not to draw the separate diagram for positive half cycles and negative cycle. That is not required. Only the last diagram you draw. Rana completed?
Yes, ma'am.
Okay. Hope others also completed. We are moving on. Okay. See, this is called half-wave rectifier. Why it is called half-wave rectification? Because only positive cycles been rectified. The negative cycles we have in rectified. The entire wave we have in rectified. Only the positive part of the wave only we have made into unidirection. Okay, that's why it is called as what? Half-wave rectifier. But we need to get the full wave to be rectified. Okay, so there is another arrangement for this one that is called as a full wave rectifier, which will be utilizing two diodes. Okay, so one diode will be connected across, another diode also will be connected together with this one, and that will be conducting during negative half cycles, and hence the entire wave can be what? Entire wave can be rectified. So it will be called as what? It will be called as full wave rectifier. One second. Okay. So how we can make a full wave rectifier? In order to get a full wave rectifier, suppose there is a transformer that we are connecting towards a diode D1 and another diode D2, and across that we are connecting a load resistance. Remember one thing, here we are connecting the load resistance to the center tap point of the transformer. Okay, not exactly the same way that we have connected the load resistance in the previous case for half-wave rectifier. Here we are connecting or we are utilizing the transformer as a center tap transformer, means the voltage will be divided equally over there. Okay, so that's your load resistance AB. Now that's a positive side and this is the negative side. Now, when positive cycles comes, what will happen? The diode D1 will be conducting and you will be getting an output. When see where you are having, wait a second. So when positive cycles comes, this N will become positive and this is becoming negative. Okay, so this diode D1 will be conducting, D2 will not be conducting. Okay, hence output will be having the positive cycle that been conducted or contributed to by the D1 diode. Now, when the direction changes, what will happen? The first part, this part will become negative. When the direction changes, this is becoming negative and this will become positive. So this diode will not be conducting. D1 will not be conducting, but D2 will be conducting because this part become what? Positive. So D2 will becoming conducting. Once D2 conducts, again output will be getting. So this output is due to what? Due to the negative cycles that is making diode D2 forward biased. Hence, D2 will be conducting, it becomes forward bias, and hence output current will be appearing across load current. So that current will be getting. So thus, for both the cycles, for positive cycles and for negative cycles, we will be getting what? output across the load resistance. So for positive cycles also we will be getting, negative cycles also we will be getting. So the entire wave can be rectified. Okay. So when the diode rectifies the whole wave of the AC wave, it is called as a full wave rectifier. During positive half cycle of the AC input, diode D1 conducts through the circuit, through the branch BA, and during negative cycles, the diode D2 will be conducting and the current will be appearing through BA. BA means the load resistance we are saying. Okay, so this is your full wave rectifier. The explanation or the notes for the working of these diodes, I will be giving you, or I will be WhatsApping you. I'll be giving you the message through the WhatsApp group. Okay, so the working for half wave rectifier and full wave rectifier, I'll be sending you. Okay, just write down what is full wave rectifier and how it is working. Just a short note you are writing now. Just write it down. One more feature is there. Means you can still see some ripples over there, right or not? Okay. See how we used to draw DC current. DC current used to be draw like this. Yes or no? Now I am having a DC current in this way. Like it is unidirectional, but still what we are having, the ripples we are having, means the AC feature is still remaining. So I have to filter off this AC feature. So in order to filter off this AC feature, I will be connecting an capacitor over there. Okay, that I will be discussing later. Okay, so always remember, this is, of course, this is what? This is a rectifier. You are getting unidirectional current, but still the AC feature is still remaining as ripples over there. So you can eliminate these ripples or these fluctuations. Still the positive fluctuations are there. You can eliminate these positive fluctuations by incorporating a capacitor, because capacitor will be filtering off AC. Okay, so you can utilize a capacitor also into the circuit and you can filter off the ripple factor over there. That small variations in the AC you can filter off. Okay, so that is the full wave rectifier. So in full wave rectifier, two diodes we will be utilizing. For positive half cycles, diode D1 will be conducting. For negative half cycle, diode D2 will be conducting. Okay. The center tap is something that is making this kind of arrangement. Okay. For at any instant, the voltages at the end, this end, you can call it as the diode positive end. With respect to the center tap, it will be positive for the first one. Okay. Then the other part, D2 part will be negative with respect to the center tap. Okay. So that is why D1 will be conducting for the positive cycle and D2 will be conducting for the negative half cycle, because D1 will be reversed bias for negative half cycle because of the change in the polarity. Okay, draw the third diagram. Here also you need to draw only the third diagram. No need to draw the entire one. Only draw the last diagram. This diagram only you need to draw. Once you complete drawing, then just inform me. I will be giving you the notes for the working. I have to take another slide. So please inform me once you complete drawing the diagram. It's very simple diagram only. Just draw it. Then I will be moving on to the next slide. Only the third diagram you need to draw. Where is Haya just now? Any idea? Asna also didn't join.
She's traveling. Even Asna is traveling.
Asna also traveling. Haya also
Yeah.
traveling.
Yeah.
Okay. And Samiha is still in Coimbatore?
No, she's taking rest.
She reached back home, right?
Yeah, but she can't join.
No, that I know. I was just asking whether she joined back to family or no. Okay. I hope you completed this one. Okay. Okay. Working of half-wave rectifier. Put the heading. Working of half-wave rectifier. Working of half-wave rectifier. And you need to draw that graph. That graph used to ask. So please plot that graph. That is the input voltage and versus output voltage. How you will be getting the output voltage with respect to input voltage for half-wave rectifier. That is a graph for that one. So just draw the graph exactly how you are seeing over there. You can see that the negative cycle's been cut off, and then you write down the working. That ends you need to see, right? 1 second. Write down this one. Then I will be telling you where to write that P1, P2, etc. Okay, so during positive half cycle, you can see over here the diagram that you drew. One second. Okay. Give me a sec. Okay, here the diagram for half wave rectifier, exactly the same diagram that you drew before also, but only the one thing is that you need to write the points P1, P2, S1, S2, primary and secondary. So just write on the point as P1, P2 over here and S1, S2 in your diagram. You drew this diagram. In that diagram, just add on these points P1 here and P2 here, this point S1 here, S2 here, and you might have written across RL, you might have noted it as A and B. Just change it to XY, and these 2 points you write it as A and B. That only. Just to check out, just cross check this diagram with what you have drew, then mark accordingly. Otherwise, the explanation will be going wrong. You will be getting confused. So the markings onto the diagram for your half wave rectifier, just mark it as you are seeing in this diagram. Aaron, turn the video on. The markings only. You just change the marking as you are seeing in this diagram. Then the explanation will be coming correctly. Otherwise, it will have some mismatching. Okay. Hope you did necessary changes in your diagram. Now, the explanation. Okay. During positive half cycle of AC input, suppose P1 is negative and P2 is positive. On account of, yes, Alton.
Can you show the diagram again?
One second, I'll show. Okay, here.
Yes, ma'am. Can continue.
Okay. Now, during positive half cycle, suppose P1 is negative and P2 is positive. Then at that time, S1 become positive and S2 become negative. This is due to inductance. We haven't discussed inductance. That we have to discuss in the chapter electromagnetic induction. We haven't discussed. So just keep it as such is here. You don't have to think much about this one. Simply understand S1 will become positive and S2 become negative. Means S1 is here onto the secondary. That only you have to remember. So S1 will become positive and S2 become negative. Okay. Means what? The PN junction is forward bias and the resistance of the PN junction becomes very low, and hence current flows, we get output across the resistance RL. This is indicated in the graph above. Just write it down, cut it down. What I'm saying, again, I'm explaining using the diagram. See, over here, S1 is positive. If S1 is positive, this end A also will become what? Positive. Once A is positive, the positive part of PN junction is connected to A, right? Which is already positive. And this is what? This is negative. S2 is negative. So this part is negative. So what will happen? The diode is forward bias. When diode is forward bias, it will be conducting current. Okay, this is what we just wrote over there. Okay, write down. Working case 1, during positive half cycle, what is happening? I hope you plotted the graph also, because graph also you need to explain. So you are getting this positive half cycle, first positive half cycle. For that first positive cycle in the AC, you are getting output over there. So first half cycle been rectified. Okay. Completed or no? We have completed the theory part up to full wave rectifier only. This chapter is. Okay, so we have completed the theory part. Problems are remaining, questions are remaining, that we will be discussing once we start the class physically. Once if you complete writing this one, just give me a signal so that we can go on to the next slide. Okay. Completed? Okay. Moving on to the next slide. Now, during negative half cycle, S1 will become negative and S2 will become positive. Just the reverse that you just wrote. Okay, so S1 will become negative and S2 will become positive. So the diode will be reverse bias and resistance of the junction will become increase, hence no current will be flowing and there won't be any output in the across the load resistance. That also been denoted in the graph. You can see that for the second negative cycle, the output is blank. This process will be repeated. Thus, we will be getting current only in the positive half cycle. Hence, it is called as half-wave rectifier. Make it fast.
Ma'am, case
Yes.
2 is for the full wave rectifier.
No. Half-wave rectifier only. For half-wave rectifier, case 1 means you don't have to write it as case 1. I just forgot to write it. Case 1 means what will happen during the positive cycle. Case 2 means what will happen during the negative half cycle. Okay, we are just for the easiness of the concept, we are just splitting that into two different things. It's not two different, it's simultaneously happening. When positive cycles will be coming to the diode, it will conduct. When negative cycle will be reaching over there, it will not be conducting. That we are explaining a bit in detail, that only. Okay.
Yes,
This is
ma'am.
this is explanation for half-wave rectifier only. Why I'm telling you, because if 2 mark question is coming, you need to give out some points. You cannot simply write down in 1 or 2 sentences, but the exact points has to be given. That's why we have given note like this. What will happen to the PN junction? What about the resistance? Whether it will be conducting or not? This kind of points has to be given. Completed, right? Okay. Now the explanation for full wave rectifier. Again, here also you just mark and your full wave rectifier diagram. The same diagram only, center tapping only, but been represented in a different way. Okay, you need not to worry why this diagram is. This is also one way of drawing the same diagram. Okay, both way you can draw. Here what it is that instead of connecting that RL directly to the sender tab, the sender tab has been taken out a separate terminal and then connected externally. Means in the circuit diagram it been connected like that. That only, there is no other variations. Both the diagrams are same only. You just write down the points like P1, P2, S1, S2, you write down, and A and B also you write down. Okay. So same diagram only. The graph also you have to write. Draw the graph.
Should we change the diagram like this?
If you want, you can change, no problem. If you want, you can change. Means if you want to change, you can. But both the diagrams are exactly the same. Both way you can represent. I think in your textbook, this is the diagram that been given. You can refer back to your textbook. Whatever it is correct. Both the diagrams are correct. You can see the output. See, RL is connected to Y and the Y is in turn connected to a sender tab. That's it. Both are correct. Both way you can draw. Draw the graph like that. Aaron, please turn the video on. The observer is requesting you. All of you who join, why you are turn off the video? Why you are turning it off? No need to turning it off, right? Just plot the graph. Okay. Now, the explanation. Write down. Okay, let us do one thing. I have another section for grade 10. I won't be able to complete this particular one. This note I will be sending. Okay. Okay, because I am having 10C session. So I cannot continue, only 2 minutes been there. So 12:50, 12:55, I have to join over there. So the notes for the working of full wave rectifier, I will be sending you. Okay, so we have completed the chapter semiconductor physics. Just read through it, mainly theory only but lot of theory is there. Lot of questions will be coming from all the sessions, starting from energy band diagram. Energy band diagram, P-type, extrinsic, intrinsic semiconductor, P-type, N-type, PN junction, potential barrier, depletion, then PN junction diode biasing, forward biasing, reverse biasing, VI characteristics, then resistance, dynamic resistance. There also reverse saturation current, knee voltage, then rectifier. Okay, all these things are, so many theories are there. All these are very important. Okay, there is not even a single topic that you can left. All the topics been frequently asked in the CBSE board examination. So do not leave any topic. All the diagrams that you are having in your textbook is very important. All the diagram, they used to ask you about energy band diagram for metals at room temperature, or means all metal semiconductor insulators. What will happen at room temperature? What will happen at 0 Kelvin? All these things they will be asking you separately. All the diagrams are important. So please learn all the diagrams. Okay. And be ready for the board examination. Also for your half yearly examination. We are almost towards the end of the chapters. Only 4 chapters is remaining. The two chapters that we yet to discuss is electromagnetic induction and AC. That we'll be discussing once we'll be having the physical classes in the last week of August. So 2 chapters we'll be completing then. Then the next 2 chapters, ray optics and wave optics, a bit lengthy, but still we'll be managed to complete that in the month of September itself. Okay, only 4 chapters are there. So these 4 chapters we'll be completing by the end of September, and we have to revise. Before that, maximum you have to complete the revision during this month, August, whatever we have discussed. I know that won't be fully completed, but still, as far you can complete it. Okay? Anything you want to ask me? Any doubts regarding anything? Please. Okay? If it is not there, then we can stop this session. What's the time there? It's 10:20, right? 22, 23, right? Okay. Okay, we'll stop it there because I need to join the next session for 10C. Okay, thank you all for joining. Please do revision properly. Complete the record works. If you have any doubt, please ask me. Project also you need to complete. Okay. Do not take simple topics. Okay. It has to be of the standard of grade 12. Okay. And it has to be from your grade 12 syllabus. Shall not take anything from your grade 11 or grade 10. Can be of higher standard, no problem, but shall not make anything that is very simple. Okay. Okay. Thank you all. Thank you all for joining. Bye.